Alright, this is a video for 5.7 for Pythagorean theorem. Now I know you all know how to do Pythagorean theorem. This is going to be a review of that, plus some applications, and a little bit higher when we start talking about doing it with variables. Okay, so you all know the Pythagorean theorem, a squared plus b squared is equal to c squared. The only thing you have to make sure of is that c squared is always the hypotenuse. You can use a squared and b squared interchangeably, it doesn't matter. So here, this is the hypotenuse because it's across from the right angle. So this has to be c, this can be a, and this can be b. So here we go. A squared plus b squared is equal to c squared. 4 plus 36, 40. Now if we have x squared, I'm after just x, not x squared, so I have to square root both sides because the opposite of squaring is square rooting. So x is equal to the square root of 40, but we talked about we have to break that down. 2 and 20, 2 and 10, 2 and 5. So the square root of 40 is 2 on the square root of 10. Has to be a reduced radical. Okay, b looks a little different because we have variables instead of all numbers. Okay, so this is going to be, we'll call this a, b, and c. So this is x minus 2 squared plus 4 squared is equal to x squared. Now, the big thing people want to do is to distribute this squared through there, but that's not what it means. Remember, 4 squared really means 4 times 4. So x minus 2 squared really means x minus 2 times x minus 2. So don't forget that. That's a bad habit people do. And then we can FOIL this together. So first would be x squared. Outside would be negative 2x. Inside would be negative 2x. And last would be positive 4. Okay, so this is x squared minus 4x plus 20 equals x squared. Now if we have x squared over here and an x squared over here, those actually cancel out. I'm going to move the 4x to the other side. So I have 4x is equal to 20. Divide by 4, x is equal to 5. Now, that's a lot of work there, so if you're not comfortable with that algebra, go back through there. But we could go back and plug these in. X is equal to 5, x minus 2 would be equal to 3, and then you could go back and do Pythagorean theorem with 3, 4, and 5 and make sure that it works out to make sure that you got the right answer. And hopefully we know 3, 4, 5 is a right triangle, but if not, we will in a second. Okay. Alright, now the word problem. The only good thing about word problems is that you can use decimals. You don't have to use the reduced radical form. So Randy is building a rectangular picture frame. So I'm going to stop and draw a rectangle. He wants the ratio of the length to the width to be 3 to 1. So all that means is however long the width is, let's say x, then the length has to be 3 times as long as that. Now I have to use variables. I can't use like 1 and 3 because I don't know if it's 1 and 3 or 2 and 6 or 3 and 9. I just know it's 3 times as long, so I'm going to use variables as my placeholder. And the diagonal is going to be 12. How wide should the frame be round to the nearest tenth of a centimeter? So we have this problem set up just like we had this one over here with the variables. So this is a right triangle because it's a rectangle. So I'm going to do Pythagorean theorem. X squared plus 3x squared equals 12 squared. It's important to put this in parentheses, otherwise you're going to mess up and it doesn't count. So this is x squared. This is 9x squared because 3 squared is 9, and then x squared equals, whoops, how about we do 144? 10x squared is equal to 144. Divide by 10. X is equal to 14.4. X squared is equal to 14.4, and then we can find the square root of that. I did that on the back, and we could do 3.79. So check the math and make sure you get the same thing there. Oh, round to the nearest tenth, so I can call this 3.8 centimeters. Especially with these, with the variables, I would encourage you to go and plug this back in and do Pythagorean theorem. This is 3.79. This is 11.38. Now, it's going to be a little bit off because you did round, but when I went back and checked these, I did 3.9 squared plus 11.38 squared and hit enter, and I got 143.8 or something, which is pretty close to 144, so I know I got pretty close. Okay, let's see. Alright, a set of three non-zero whole numbers, a, b, and c, such that a squared plus b squared is equal to c squared is called a Pythagorean triple. All this means a Pythagorean triple is three good whole numbers that work out for Pythagorean theorem. And if you can memorize some of these, that will save you a lot of work down the road. So here's the four most popular. 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Now, if I would encourage you to put these like on a flashcard and just carry them around with you for the next week or so, because honestly, the better you can memorize these, you're going to save yourself work later. Also, what works is multiples of these. So instead of 3, 4, 5, I could do 6, 8, 10, and that would also be a Pythagorean triple because all it is times 2, times 2, times 2, so it's still a 3, 4, 5. So it's also worth your time to check for, is it a multiple or is it not? Okay. Alright. So this one, 4 and 12, so I could reduce that. I could divide by 4, that would be 1 and 3, but that's not any kind of Pythagorean triple, so this one isn't a triple. I'm just going to have to do this one the normal way. A squared plus 4 squared is equal to 12 squared. A squared plus 16 equals 144. Move the 16 to the other side. 128. So then we take the square root of both sides. And then let's break down. 2 and 64. Now, if you know your perfect squares, this will help you a lot. Because instead of breaking this down, 2 and 32, 2 and 16, blah, 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 64 is a perfect square. So I could go ahead and call this 8 and 8. Then I don't have to stand around and do my tree forever. I can just say that the answer here is 8 on the square root of 2. And I'll save myself a lot of time. Okay, let's look at B. So 24 and 26, those aren't any of our Pythagorean triples because our triple we want is 24 and 25. But if you think about, if you divide this by 2, that's 12. You divide this by 2, that's 13. So this could be a 5, 12, 13 triangle. 13 is the hypotenuse, 12 is the longer leg, so this has to be 5. But 5's not your answer because you had to divide everything by 2. So actually, 10 is your answer. Then, this is the beauty of looking for a Pythagorean triple because 10's my answer. That's it. I don't have to go and do all this stuff. I don't have to do the tree or any of that business. I just have to write 10 down on my paper. Okay, the converse of the Pythagorean theorem is in your vocabulary grid. And with the regular Pythagorean theorem, you said, okay, so if it's given that it's a right triangle, then I can do a squared, b squared, c squared. The converse of that is exactly backwards. If a squared plus b squared equals c squared works, then it must be a right triangle. So it lets me say, okay, given the side lengths, if I tell you this is a 5, 12, 13, then, oh, okay, that works out, so this must be a right triangle after all. It lets us work backwards. Okay, using that converse, we can use an extension of that is what's called the inequality theorem. And it says, well, if it's not a right triangle, if it doesn't work out, then what is it? It's either obtuse or acute. So how you have to look at this to remember this is you look in terms of what would have been the hypotenuse. Okay, so if this works out exactly right to be a right angle, then this is going to be the length of my hypotenuse. But if I stretch C out, if C used to be this long, if I stretch C out, then this angle across from C is going to get bigger and bigger and bigger, and it's going to be an obtuse. So if C is too big, then the triangle is obtuse. If it used to be a right triangle, but C got smaller and smaller and smaller, then C is too small. It's like Goldilocks syndrome. So this must be an acute triangle. If C is too big, it's obtuse. If C is too small, it's acute. Okay, let's see how this works. Now, to do this, you have to make sure A and B are the little numbers and C is the big number, just like you do in Pythagorean theorem. So you'd say 5 squared plus 7 squared, maybe it's equal to 10 squared. And you can do this part in your calculator. 25 plus 49, how does that relate to 100? So 74 is less than 100. Now you have to think about this from the C's perspective, from what would have been the hypotenuse. And in this case, you say the hypotenuse is too big, so this is an obtuse triangle. Okay, it's not that this is a less than sign, because this is not the hypotenuse. This over here, so you have to look at it from this direction. This is too big, so it's an obtuse. Okay, let's try 5, 8, 17. So 5 squared plus 8 squared equals 17 squared. Okay, 25 plus 64. I left my calculator at home, at school, so you'll have to excuse me, I don't know my squares all the way up. 289. So 89 is less than 289. So again, I didn't pick a different example. The hypotenuse is too big, so this is an obtuse triangle. Good. Oh, that's the end of 5.7. So tomorrow in class we'll practice a few of these baby ones, and then we'll do some real applications, some word problems to make you think about it problems. See you tomorrow.